In last video, I talked about Azure functions, what they are, why to use them, when not to use them, when I would use them, and that's what I'll zoom in on today and how to get started. I see many of you haven't watched the video yet, so do check that out. And as always, I will be leaving my slides and code on the Patreon, so make sure to join that. There you can access most of my code. If you want even more access to my best NuGet packages, sign up at kiscode.com and I'll make sure you get those. So let's say a page visitor of one of these web applications want to make a purchase. Then they initiate that, after which a window opens to the payment processor, which is an external service like Stripe or Molly or whatever you use. Whenever that payment was successfully processed, and in the meantime, we'll get some notifications from that payment processor letting us know what the status of that payment is. To receive these notifications from the payment processor, I have to make one of my HTTP endpoints public. So then that post request with the notification status comes into the utils API on one of its endpoints. And then, because I don't want to cross the boundaries, so I don't want this utils API to directly post into the database of another API or directly to their APIs. I don't want to do that. That's why I kind of decoupled that using a message broker. So whenever that notification comes in, the utils API creates some kind of reference record in the database. And then afterwards to do something more specific, which is create a record in the pet service database or in the pet adopt database to prevent posting directly to these APIs or databases. I use the message broker, so that depending on the message type, which is included in the metadata of the notification object that I set with a custom property, depending on that type, the message that now is available in the message broker can be either processed by the pet adopt worker or the pet service worker, so depending on that type. But these workers, they are constantly polling, so constantly asking the message broker, do you have anything for us? And they keep doing that every 5 minutes, because these messages should be processed as soon as possible. So these workers have to be constantly on, always on. So I'm paying for the entire month for both these workers, while there may be only a few messages a week, maybe just once a month. If it was the case that I had received messages every, let's say, 1 minute or more frequent, then it wouldn't be as wasteful to have these workers constantly running. But all in all, a cloud function will likely reduce the costs. Seeing the utils API, which would send the message to the message broker, and then I forgot a line. And then the message broker, whenever a message comes in, so then an event triggers, so the queue event or the message event triggers that cloud function, and that Azure function can then process that message, do whatever it needs to do, and then finally write the result of the processing to either of these databases. And maybe you have spotted a better scenario. So a scenario where we can even take out this message broker entirely and just have the payment processor directly post to the Azure function by replaced this message queue by just saying that it's now the external payment processor, which was previously not in the picture. That's going to post, so with its webhook technology, it's going to post to my Azure function directly whenever there's an update for that payment. The Azure function processes that payment status and the metadata, and based on that it will write to the correct database. So let's take a look at the cost breakdown and figure out whether we're actually going to reduce costs or not. So I'm currently paying 75 euros, that's about $80 a month, for this setup that you saw on screen. We got rid of the message queue, the message broker, so that's going to save us some costs. These workers are going to keep running because they're performing other tasks, so that's not a cost reduction yet. So back to the costs. The main cost that will disappear is this service bus namespaces one with €4.50, so about $5, a reduction of $5 each month. So let's now actually build an Azure function and deploy it. If you are a Visual Studio Code user, you can install one of the following packages, after which you could easily create cloud functions, Azure functions, and you might have to connect to your Azure portal to then actually publish. If you are a Visual Studio user, you can also do that, but make sure you go to the Visual Studio installer and check whether you have the proper setup. So if you click modify, make sure you have this Azure development checked and installed. That will allow you to run things locally, so these Azure functions, and then publish them to Azure and connect to your Azure portal. However, I'm going to set it up using the GitHub Actions and the workflows. For that, you start in the Azure portal, you create a function app, and then you connect that to your GitHub account, a bit similar like we did before deploying all of the app services, the .NET APIs to an app service. So, and this flow is also similar as you would expect with an Azure app service. And then the hosting options and plans are very interesting as well. I briefly touched on that in previous video. The consumption plan is basically the pay-as-you-go and is likely the most interesting to us. Functions Premium is just a premium version of that consumption plan, which has some extra benefits like warming up. So whenever then some task needs to get performed, it will be instant. And with the normal consumption plan, that might just take maybe a second more because it has to come out of the cold start, come out of the sleep mode. And then you have that app service plan, which is if you really need way more resources. That's when function execution time of 5 minutes or 10 minutes is not enough. So if your task takes 6 minutes, too bad. It likely won't finish because the functions have a maximum execution time of 5 minutes. Then for the premium, that's extended to 10 minutes. And then for the app service plan, that can go up to 30 minutes. But that's an app service plan. So you're basically, it's almost the same like running your background worker services on a app service. Okay, let's go next, because we'll need to go to the deployment, but let's see what else they have in store for us. I think I just want application insights, enable public access. That's going to be necessary because the payment processor needs to be able to access it. If I were to turn that off, then only internal Azure services could access this app. So I'm just gonna pick that one. Feel free to create a new one if you prefer to keep that separate. And now that's where the CI/CD comes in. So we're going to enable that. And I'm going to select the, so many paths, and I'm going to start off with the main. Okay, it's telling me Linux dynamic workers are not available in the resource group. So it looks like a function app, since its dynamic nature, it can't be added to an already existing resource group that contains non-dynamic resources, like all of my app services. Because of this SKU being dynamic, and yeah, that auto scaling that's involved in these functions, that might not work well with a resource group that also hosts app services with a manual scaling process with a fixed tier and so on. So okay, let's just create a new one. I am now maybe going to add a new application insights thingy involved there. Let's see. 5 selected. Okay. So let's see. It says next steps, create a function, manage deployments. So what I can assume now is that it hasn't actually created any function yet. It didn't create code in my GitHub repo or anything, so that's good to know. What did get created is that GitHub Actions workflow configuration file, which should now live in my GitHub repository. So I created this functions folder at the top, solution folder, in which I want that payments webhook project to live. And by now I pulled my new workflow file from GitHub and merged with the dev to get it in here. So let's take a look at. So we've got a nice .NET 8 version. That's what I like to see. So this path we're going to have to alter. These branches I'm also going to alter. I'm going to want to deploy a new version anytime I create a release branch starting with either payments or payments webhook. To create an Azure Functions project, we'll need this plugin, Azure Toolkit for Rider. So going to settings, plugins, and let's see, Azure. Azure Toolkit for Rider. I hit restart and we should be good to go. Adding a new project. And the Azure Functions is at the top. Rider requires the Azure Functions core tools. And now I can finally create one. I just call it payments webhook. I'm going to select the isolated worker because that's the runtime we select, the version we selected on the portal as well. And then we get this nice project with a program CS. That's nice because there we can configure our dependency container and everything else. Local settings JSON, it's to successfully run locally. Hosted JSON, that's a bare bones configure functions worker defaults. Let's dive into that later. And if I take a look at the properties, it's just the launch settings. So now we don't actually have the actual function, we just have the functions app. So we can add a new function, and this is where you see all of these triggers. I briefly touched upon these in last video. So the timer trigger is that scheduled one. HTTP trigger is the one we'll need. The queue trigger is that one that could act on the message broker. Well, or either one of the below. Cosmos DB trigger, that's cool. Anytime a record is modified, or yes, any changes happen in the Cosmos DB, then you can send out some kind of notification to the function, which can then email you or do whatever. That's cool. SQL trigger, I assume that's something similar, but on a SQL database. And then the blob trigger is also similar, so a change event that occurs whenever a new file is uploaded to the blob store or modified. Then you can send those changes over to the Azure function and act upon that. Let's take the HTTP trigger. Okay, to resolve these red ones, I needed these NuGet packages. So let's take a look at the actual functions. So we can use the dependency injection and we can access the logger. First we see the name of the function, that's payments. It's a bit like the endpoint name. So we could do /payments. I only want to accept the post method for now. And I'm just going to call this request. So then that HTTP request data, that will be similar as in a regular API, the request data sent by the host. Okay, and then the function context is more information about a function execution. Then we have the logger, and then you kind of have to build the response yourself. And the reason for that is so you could alter that to maybe return a different content type, like either JSON or XML or maybe a file, and so on. And of course you can just copy these functions to add more functions in here, or just create new ones. .write as JSON async. That's probably going to be better. Let's just have like an anonymous object. Write as JSON async is a void, so it has no return type, but will add your class object as JSON to the response. And then we don't need that write as text anymore, of course. And here we'll want to change it to application. And then I think it's JSON. And HTTP status code, so you could say okay or no content. I'm gonna go for no content and then leave out maybe that. response, because my payment processor just needs a success status code. So let's see, requests, what can we do with that? We can access the headers, function context, query parameters, query string parameters. Then the body is a stream. You can also, like you're used to in regular APIs, you could also add a from body tag and then have your custom object type and then say request body. And then finally this authorization level. So function is actually it's going to check for a function key, which can be function specific. So for the webhook, that could be a different key than for another function that I create, maybe even in the same file. Admin, so that master key, that would be more like a key that can access all of the functions. Okay, so there's a catch here in the writer, the JetBrains writer IDE. You can't use the regular run. Go to the configuration manager, and instead of trying to run them as a normal .NET project, I need to run them in this Azure Functions host, and I just renamed it, so it's this payments one. Okay, and then that is running and it's showing me my endpoint, so that should be accessible. So doing that in Postman, we get a 204 no content, which is fine, that's a success thingy. And then we get the output logs underneath. And you see this prefixed, this is prefixed by API. You could change that if I'm not mistaken, and according to the docs, something like this, HTTP, and then say route prefix and change that into something else. Maybe you just want to call it functions. And now that should be accessible on functions. Let's see, functions. Yeah, that works. Let's see, so you've got the host builder context and then the functions worker application. And usually they kind of add the middleware in here, so the middleware for the function. But you can also have a, let's see, configure, app configuration, host configuration. You can also say configure services. That might be a better idea. Let's just say services. So I gave it better names. So host context, function context, host context, services. Or we could even call this like a builder. That would resemble our original apps or minimal APIs and our MVC APIs more. And then you could say builder.configuration or even builder.services. No, hosting environment. So a lot of cool stuff. And then to finish up the Azure function, we're going to add Serilog. Doing that in the host JSON. I'm just going to add that at the bottom. Remove this application insights logging. This is the production setup. This is a nested JSON configuration, which is not possible in the local settings JSON. If you want complex properties, you need to divide them with a colon. Unfortunately, that does not seem to pick up correctly for running Serilog locally. But if you had any other custom properties, just know that's how you should do it. And you could likely do it as follows. If the host context is development, write to console, else just use the configuration. It's not that clear, but this abbreviation of info points to successfully using Serilog. I don't think I'm going to use it locally because that's not going to be that big of a benefit, because in a local console you can't really see all of the extra context data and parameter data, just the log message worker flow. So let's see, GitHub payments webhook. So I could make a branch payments webhook and say like init deploy, but we still need to change this one. So let's see what we can do. Should be functions, so pointing to my, and then payments. Let's see. Okay, so everything deployed correctly, and I already tried to post to the function with Postman, and it gives me a 401 because it needs that function key. And the function key we could add as a query string parameter, apparently, by adding code equals and then the actual value of that. Where to find that is if you go to your function app. You can have the app keys in here, but that's about the master key. But where to find these function keys is if you click on the payments webhook. So that's actually the function itself, the endpoint itself. And then you can go to function keys. Okay, since these functions key don't really want to load, I just quickly entered my default key from the app keys, the default one. And then I do get a 204. But I'm not going to show you because that key is included. I'm going to end the video here. I hope this was enough information to build amazing Azure functions. If you want to learn more about what, why, and when to use them, so about the use cases, what else you can do with them, go back to watch this video. If you want to access the slides, do join my Patreon, where most of my code is available and these slides. And if you want even more access to my best code, you can get my most commonly used NuGet packages for free, the original code that is, by signing up, and I'll make sure it ends up in your inbox. And a limited time offer, a fully working brand website with blog functionality and tons of ways to capture and interact with your audience, that is available on my Patreon as well. And that looks very similar as my original website with most of the capabilities in there. I hope I see you in the next video. Don't forget to like and subscribe if this video brought you any value.